Okay, this topic is pretty tricky. It's called iteration. And what we're going to do is we're going to look at what iteration is and how we actually use it. And the first thing we need to know about iteration is it's a way of solving an equation. Okay, so we have lots of ways of solving equations, like factorizing brackets, solving equations using reverse of BIDMAS, and all of that sort of stuff that we've been talking about. Iteration is just another method. So let's just have a look at this equation here, x cubed plus x equals 7. We have no idea really how to solve this. And so iteration can help us when we have an equation that we don't know how to solve. Let's just have a sort of exploration, I guess. Investigate what this function looks like. X cubed plus x. And then I'm going to make it minus 7 so that we can put it equal to 0 and try to have a look at what the graph looks like. I'm going to go from minus 5 to 5 and we'll step up in ones. So we can see that when x is minus 5, this graph is very negative. Okay, and as we approach 0, then the graph gets more positive. And then between 1 and 2, it actually jumps from negative to positive. It goes up again, and it just seems to increase. Okay, so a cubic graph usually kind of looks something like this. Okay, this one might be doing something like this. Because we saw that on the graph, something interesting happened between 1 and 2. Yes, so from between 1 and 2, so x equals 1 and x equals 2, the y coordinate became positive. It went from minus 5 here, minus 5, to 2 being plus 3. And so what we found just with that little investigation there is that between 1 and 2, the graph broke the x-axis. It crossed the x-axis. And that process of finding this coordinate here where it crosses the x-axis is what we do when we actually solve equations. We're looking for this x-intercept. Okay, so just in that process, we've seen that between 1 and 2, between x equals 1 and x equals 2, we saw the y coordinate change from negative to positive. So we have a sign change. Okay, so sometimes in this topic for part A, they often ask you to show that there's a solution or a root between x equals 1 and x equals 2. And all we have to do is put x equals 1 into this solution, into this formula. X cubed plus x minus 7 equals 0. Okay, we make it equal 0. When I substitute 1 into here, 1 cubed plus 1 minus 7 is negative 5. And when I put 2 in, 2 cubed is 8, plus 2 is 10, minus 7 becomes 3. So all I have to do is substitute x equals 1, show that it's negative, do x equals 2, show that it's positive, and then we can say that there's a sign change, so there is a solution between x equals 1 and x equals 2. Okay, already I know that that's probably quite a lot, but we just put some numbers into a formula and showed that it went from positive to negative or vice versa, and that's all we have to do. For part B, they will ask us to rearrange this equation into a certain form. Okay, so show that this equation, x cubed plus x equals 7, can be written, sorry about my writing here on the pad, in the form, and then it will give you the form that they want. So it might be something like x equals the square root of a plus bx or something like that. Okay, and what we do is we have to try to rearrange this thing and make x the subject. Oh, there might be a little cube root or something like that. So when we do this, we're doing a rearrangement to try to match this form. Okay, so if I rearrange this, it would look something like this. Is just an example. Okay, I could rearrange to make this one the subject, or I can make this x the subject. Okay, if I choose the second x, it will just be 7 minus x cubed, which isn't this. So that doesn't work. And the clue is in the kind of cube root like this. So I'm going to have to make this one the subject to get the cube root at the end. So x cubed equals 7 minus x, and then x equals the cube root of 7 minus x, like that. Okay, so we've just done a rearrangement, and to be honest, sometimes this rearranging part can be super difficult, and if students don't get it straight away and they don't see it, they usually just leave the part C where we actually do the iteration, even though you don't need part B in order to do that. Okay, so this is the iteration part itself. What we're going to do is we're going to substitute a number into our equation. They will give you that number to start with. This number is called XO or X0, and they will tell you in the exam what they want you to start with. So let's say it's a 1. Okay, you put your 1 into this formula for x, not this x on the left, the one on the right hand side. Okay, the one that's not the subject. And you calculate this using this value that they've given you. Okay, so you're going to put 1 into this right hand side of the equation, never the left part. Once you get that answer, which will 9 times out of 10 be disgusting, you take the result of that and then you re-put that back in to the equation. So you continuously go in this cycle, a bit like compound interest. Add 10%, add it on. Work out 10%, add it on. And you do this sort of iteration process. Iteration just means cycle. So we can put 1 into here. I'll just write out what that looks like. 7 minus 1. So the cube root of 6. Okay, your calculator is going to do all this for you. The cube root of 6, horrible decimal. But then we take that answer and we put it back into here. 7 minus that horrible decimal, take the cube root. That will give us another decimal, another answer. And then we do the same process, usually about 3 times. Okay, so let's just get our calculator out and have a look at what that would look like. I want to do the cube root of 7 minus 1. 1.817. Okay, and then I do the cube root of 7 minus the last answer, because the ANS button is going to be your best friend for this topic. 1.73. And then I do the cube root of 7 minus this answer. Well, the calculator already has that, so I just have to literally press equals. And this will be my 3rd iteration, my 3rd time through the cycle. Okay, and what you'll find is this number that we're getting, this 1.74, is an approximation of the root or solution. It's 1.7 is going to get closer and closer and closer to the actual answer. If I keep pressing this, you can see it's getting more and more accurate. 1.739. Okay, so by rearranging our original equation into this crazy form, yeah, that's quite difficult, but the iteration process is actually just a case of putting some numbers into your calculator. And the way that I do it in the exam is to take XO, which is 1, press equals, and now your calculator with the ANS button will remember that. So I can literally just start with cube root 7 minus ANS. Excuse me, so it's remembering that 1 that I put in first, and then I can just go 1, 2, 3. And they are my 3 iterations through the cycle. So we write this as x1, which was my first one, 1.817. x2 was 1.730. And x3, 1.740, like that. So this notation can be scary, but we're just saying 0 is the one that they gave us, the starting position, and then the first, second, and third cycle through. Okay, I know that's tough, and this video is about 10-11 minutes long already, so I'll try to wrap it up there. But when you see this XO, put that in your calculator, and then on the right hand side you will usually see like an XN. Wherever you see that, that's where you write your ANS from your calculator.